Hello friends. So today in this video we will discuss about the divergence of electric field E. So we all know what is divergence. Divergence is the rate of which the field is spread out. The rate at which the field is spread out is known as divergence. How much amount of field is spread out, or we can say diverse or converse, is the divergence. So we want to find out the divergence of electric field E. So we have the equation of electric field and that we have derived, and it is the equation number 7. So now we calculate the divergence of electric field from equation 7. So the equation 7 is electric field E is a function of R is equals to 1 upon 4 pi epsilon 0 into integration r cap upon r square into rho r. Rho is a function of r into d2. Okay, so this is the electric field, equation of electric field, which we derived earlier. So now to find out the divergence of electric field, we will take the divergence on the both the side of this equation. So this equation becomes del dot E. Del dot E, it can be written as del dot E or divergence of E. So del dot E is equals to 1 upon 4 pi epsilon 0 into integration del dot r cap upon r square into rho of r into d2. Divergence is applied to r cap and r square and the rho r, because 1 upon 4 pi epsilon 0 is constant. So divergence is applied to this remaining term. Okay. So now from Dirac delta function, uh, we can have the relation, that is del dot r upon r square, and it is value of it is 4 pi del cube r. So where del is the Dirac delta function. Okay, so we can put this value in the above equation. So it will become del dot E, or divergence of E, is equal to 1 upon 4 pi epsilon 0 integration, and instead of del dot r cap upon r square, we can put the value it, that is 4 pi del cube r, and the remaining term, that is the uh, charge density, volume charge density, rho r into d2. Okay, so from this equation we can cancel out 4 pi from denominator and numerator. So and the remaining term, that is del dot E, is equals to integration del cube r rho r into d2. So the integration of del cube r and d2 will be 1. According to Dirac delta function, the integration of this term will be 1, and the what remains, that is volume charge density rho r. So del dot E, or a divergence of electric field E, is equals to rho is a function of r upon epsilon 0, and it is the equation number 25. So equation number 25 is nothing but the Gauss's law in differential form that we derived earlier, Gauss's law, and it is in the differential form. So again, now we will convert into the integral form, and for that we will take integration from the for in equation 25 on both the sides. So equation 25 becomes integration or volume V del dot E into d2 is equals to 1 upon epsilon 0 integration over volume V rho d2. So this is the question number 25. If we take divergence on the both the sides, so now we apply divergence theorem. Divergence theorem that you have studied earlier. So it will convert volume integral into the surface integral, and provided that uh, the operator del will be vanished. So on the left hand side of the equation, the volume integral converts into the surface integral. So it will become closed loop integration over surface as E dot dA. Here dA is the surface element, and it is equals to Q enclosed upon epsilon 0, because integration over volume V rho into d2. If we integrate this term, then we get rho into V. Rho is the volume charge density and V is the volume. So it rho into V, or instead of rho into V, we can write Q enclosed, charge enclosed within the surface over surface S. So we can write Q enclosed instead of integration over volume V, rho d tau. So the equation becomes integration over surface S dA dA is equals to Q upon epsilon 0. So this is the Gauss's law in the integral form. So if we take divergence of electric field E, we get the Gauss's law, that is in the differential form, and we converted it into the integral form. Okay, thank you for attending this.